Okay, here we are again, one more time. So pop your name in the chat box. Remember that counts as your register. While you guys are doing that, I'm just going to quick run to Dr. Frost Maths and see who's done their homework. Log in. What do I see? Manage classes. This is set work. Few homeworks, that should be good. Okay. By task, quick class select. That's the further. I hate the spreadsheet system it's using. Okay. So we've got E-Man, Rebut. I'm looking at the Dr. Frost Maths. That's garbage as well. I'm going to be real with you. If this doesn't improve by Thursday, I'm smacking a whole lot of you on course of concern. E-Man, you said you've done some of the questions. I haven't got your pictures yet. So you pop that for me as quick as you can. This is poor. This is dismal. I'm not going to have this. We'll hang around, see if a few more people show up. If people are getting, again, I'm just not totally unsatisfied with this. Having had 2 weeks to do your homework, it's not been done. Issue. I'm just saying that I looked at the Dr. Frost work. That's not been done either. I mean, what are you guys thinking at this point? If you're thinking this is extended holiday for 3 months, think again, my dude. It will be like a permanent holiday because I'll boot you out personally. No doubt about that. All right? Because at the end of the day, it looks bad on me if you guys are not working. And you're not working. I still haven't received any other photographs of work other than Reba. Then I'm looking at Dr. Frost Maths and 3 people have done one and 2 people have done the other. What are we thinking there? I'm going to give you till Thursday. If the work is not done by Thursday, automatic course of concern. All right? And then I'll start rolling people out of the class. You cannot think this is a holiday. You have to work. If you don't work, you will fail. And you can fail somewhere else. You don't need to fail at Candy. That's my opinion. You don't need to drag my name down because you guys can't be bothered to work. I will not have it. E-Man, well done. I managed to see some work. Good. I can see that. That's good. As far as I'm concerned, if you show me you got work, I've got no problem with you. And so far, Rebut has shown me he's done work, and E-Man has shown me he's done work. It's fine. Yeah? You Rebut, I saw. I checked. Yeah? I'm checking. In fact, I've got it on the screen now. I can tell you who's done what. I can tell you who's made effort. E-Man, it doesn't look like you've done the integration by parts. There's no answers here. I can see Rebut's done it once, and Kai-san's done it, and Shiying's done it. Yeah? So them 3, they've done integration by parts. Good on you. The rest of you guys, what were you thinking? For the second one, substitution, nothing from E-Man, nothing from Farhan, nothing from Morella. Rebut again. Good effort there. Kai-san, good effort. And Shiying as well. Sorry, I take that back. It looks like it says completed, but at least 3 of you tried. Yeah, that's something. All right. You all need to be working. You're working as hard, or if not harder, than you'd work at college, because this is not as good a way of doing things, obviously. Right. We've got 6 people. What I'm going to do is I'm going to first answer the question that, yeah, I saw it. I'm going to read that. I understand. As I said, I've got full respect for people's life situations, and my condolences on your loss, by the way. I hope your family are doing just fine. All right? I expect you to do your best. I don't expect you to be Superman. I'm not expecting perfection from you. All right? I want you to do your best, and that's all I'm going to ask. Yeah? Now, let's talk it out. Now, there's loads of different ways of proving the integral of sec x, but I'm going to show you by far the most stylish. Okay? And that is, I mean, just take this as your warning then, yeah? You slipped up once, it happens, all right? Don't let it happen again. And you didn't sleep for 2 weeks straight. And I can see that for the Dr. Frost work. So I'm willing to give you a benefit of a doubt, Kai-san, because at least you did a Dr. Frost. There's effort there. All right. Okay. Anyway, let's move on now. You heard what I've got to say, and you know what I'm going to do on Thursday if it's not the way I want it to be. All right. So I'm not going to keep threatening you. Let's just get on with it now. The most beautiful and elegant way to prove the integral of sec x, as far as I'm concerned, is this. Go, okay, that thing is the same as sec x. And I'm just turning it into a fraction by doing this. Now, you might ask me, okay, where the hell did that come from? And this is what I love about this. This is almost like a magic trick. You're waving your hand and going, I'm going to do this, all right? But it's so much more easy than any of the other proofs of sec x, the integral of sec x, that I just love it. And that's the way I would say, if you're going to remember a proof of the integral of sec x, this is the way to do it. So basically what I'm saying is that this is the same as that. Why? Because you multiply anything by the same thing, it doesn't make the slightest bit of difference. So it's like, if you said 4 is the same as 4 over 1, that's the same thing, isn't it? Or 4 is the same as 4 times 2 divided by 2. That's all I'm saying, yeah? Expand that top bracket, and you get sec squared x plus sec x tan x. And all I've done is expand the bracket, yeah? Nothing special there. Now here's the magic. Here's the magic. Let me just move that, yeah? There is a rule that says, if you integrate f dashed of x over f of x, that is just going to be ln modulus f of x. That's the rule, isn't it? Yeah, you've seen that before. Camera. Beautiful. And remember, that's a modulus sign on the f of x, yeah? So there's a rule that goes, if you integrate something and the denominator is f of x and the numerator is f dashed of x, yeah, then the answer is just going to be ln of the denominator. So let's do some maths. What's the differential of sec x? Sec x tan x. What's the differential of tan x? Sec squared x. So basically, if you differentiate the bottom bit, you get the top bit, which fits into that pattern beautifully. So what's the answer straight up? It's just this. Ln sec x plus tan x plus c. Beautiful. Yeah? Done in seconds. And there's harder mathematical ways of doing that. That is just, it just kills the question in one shot. So if you want to integrate sec x, just times top and bottom by the bracket sec x plus tan x, expand it out, show that the bottom differentiates to the top, and then the answer is just ln sec x plus tan x plus c. Beautiful, isn't it? And to me, that is by far the most elegant way of integrating sec x. Now, do you need to know how to do this? Yeah, probably. Will it come up in the exam? Maybe. I mean, the only way it will come up in the exam is if they'll go like, okay, prove that the integral of sec x is sec x ln sec x tan x plus c. That's the only way they'll do that. All right? Cool. So what we're going to do now is we're going to look at something called differential equations. So you need to, at the moment, I did mention this in the email as well, you need to have your Pure 2 books ready. It's also in the PowerPoint I sent you, but the Pure 2 book is the right one. So I'll give you a minute or two. If you can get your Pure 2 textbook open, remember the advice I gave you on this, yeah? You're going to need to have your textbooks saved somewhere so you can get at them straight away. Because obviously, they're literally the only resource we've got. And I'm just popping mine up now. So if you're using a laptop, have it as a laptop thing. If you've got it on your tablet, save it on your tablet. Save it to an email so you can just get at it quickly. Especially the Pure 2 book for at least another 2 lessons. We're going to do some further maths in a couple of weeks. We're going to do differential equations to the end. So I'll send you some copies of like further maths books if I can find any that's legal. Bear with me some more. Just taking a little while because I don't know what it is with this actually. It's unnecessarily slow. I don't know why that is. Right. So what we're going to be looking at, we're not going to do anything too difficult for this one at the moment. We're going to do solving, so 322. So if you go to page, I'm going to write that down on the, where you can see it. So it's going to be page 322 of the Pure 2 textbook. And it's right at the bottom of that. And I'm going to show you how to do it, okay? By taking you through some examples. So page 322 of the Pure 2 textbook. I'm going to give you about 2-3 minutes to get yourself sorted out for that. I did mention on the email you're going to need this. Okay? Yep, 322. I'm going to give you until about 2 or 3 minutes just to get yourself set up. All right? But also, again, if you read the email at 9 o'clock, it was mentioned in the email you're going to need the book. So don't worry about that. But follow what I'm saying. Treat it like a professional. Be a grown-up now, yeah? Your holiday's finished. There ain't no holidays. And your life is going to be worse because of this corona nonsense. Not obviously, you know, not only the threat of corona. I reckon what they're going to do is just going to go, you know what? You guys have a year to fix your lives, and they'll make the exam the same level of difficulty. So you're going to have to fix your lives. It means you're going to have to treat it like the best you can. Even though you're sitting in your house, your attitude is like, I'm working. If that don't work, then God bless, right? Anyways, 322, and I'm going to take you through some examples. I'm going to talk to you what a differential equation even is. We're going to do some very, very simple examples. On Thursday, just so you know, give you a heads up on this, we're going to do some more mechanics. And then every Monday, all the Mondays are going to be differential equations, more integration, and we're going to go into the further maths side of it. So that's the first time you did further maths with me as well. Why I'm so strong on integration is because we're going to need a lot of those same skills over and over again. Seem to have just dropped a few people. Make sure you've got that book open. I'm going to give you about another minute or so to get yourself set up with that book. So 322, have it up on your screen. Have you done that? I can see work from Xiying. Well done. So really, you could say Reba, Iman, Xiying, Kaisan. Those guys are on point so far. I mean, Iman, I want to see you on the Dr. Frost as well, yeah? It's important. Same with you, Kaisan, for today. I mean, you used to go overslept, but at least you did the other stuff. So that's something. But the rest of you guys, you're on warning, yeah? Right. About another 30 seconds. I'm going to rob off the proof of the sec x, the integral of sec x. It's 322. So Iman's been kind enough to put in the chat, so don't stress that I'll rob that out. And I'm going to take you through some examples here. And you can see where all this integration business comes into it. Right. Looks like about ready to start. See if you can see the top end of that? No, you can't. Let me move so you can. Okay. So first of all, what is a differential equation? That is a good place to start, because otherwise we're talking about something that's not defined. All right. So what is a differential equation? A differential equation is an equation where you've got either dy dx, d2y over dx squared as part of the equation itself. So here, your example is, we've got this is example 25 from the textbook, which is on page 323, so it's page 323. This particular example. Here you've got 1 plus x squared dy dx equals x tan y. And you've got dy dx as part of your equation. Okay, and we need to solve it and find out what y is, all right? So that's what you're talking about when you're talking about a differential equation. We're talking about an equation where dy dx is implicitly in there. Now, you might say to me, well, okay, can't I just rearrange and go, well, let's put the x on the other side and do arctan and make y the subject? That's not what they're looking for there. They want a y equals without a dy dx in place necessarily, all right? I mean, sometimes when we get further into like some of the further math stuff, you can't get that, but you're looking to get a y equals equation, all right? What kind of differential equation? This is called a first order differential equation, all right? It's a first order differential equation. How do I know that? Because it's dy dx. Dy dx, first order differential equation. If it's d2y over dx squared, then you've got a second order differential equation. And if it, God forbid, it went to d3y dx cubed, which it can do, but certainly not A level, then that'll be a third order. Yeah. So hopefully by now we should have an idea of what a differential equation is. Yeah. Should have an idea of what a differential equation is, and we should have an idea of what order it is. So we're looking at this example here. The one that we've got right here is a first order. All right, because it's a dy dx. I'm sorry about the plastic's a little bit off there. Right, cool. What is the method? So hopefully taking notes at this point, you are separating variables. That is the name of the method. All right. So if you look this up in the textbook, that's what they call it. And what we're going to do is have all the y's, including dy on one side, all the x's, including dx on one side, then we're going to integrate both sides. That's the method. All right. Put all the y's on one side, put all the x's on the other, integrate. All right. So that's the method, and now we're going to demonstrate it. Okay, so what do we have? I'm going to make the y's go here, and the x's go there. All right, so the y's go here, and the x's go there. That's as much about convenience as anything else. It's just that way around you're multiplying rather than dividing and all kinds of stuff like that. You'll see what I mean by that. So let's get the tan y onto this side by dividing through by tan y. So you get 1 over tan y, and I'm going to move this onto this side, dy equals x, 1 plus x squared dx. Okay, now if anyone's confused by that, I'll just move that so you can see that. If anyone's confused by that, this is your moment to say, no, I don't understand this, and say why you are confused. Don't just say you're confused. I'm going to stop here for a minute, give everyone a checkpoint. All right. So this is your moment to kind of pop up and say, I don't get this. What the hell are you talking about? Right? And obviously, I'll give you more support then. If everyone does understand it, could you just respond with yes? Okay. And also, I want to know, I mean, I know where Zaref's gone, but 5 people isn't 7 people. So the other 2 people could show up. That would be good. So yeah, you understand, Iman. Brilliant. Excellent. Well done. Well done. I need to hear from every single one of you, yes or no. So there's 6 of you on at the moment. So either a yes or a no. So I've got 1 response so far. And it does lag a bit. So Rubat is a yes, Shiying, yes, brilliant, excellent, well done, well done. Got 4 yeses. I'm waiting on 2 more people. I think one's Kelvin. I don't know where he's hiding. He's been very quiet today. Okay, I'm going to wait a few more seconds to hear from. I want to see who's on. It's as much me checking the register as well, seeing who's on and has still got it on, but is playing PlayStation in the background. I mean, listen, all of these things are not, they're obvious, right? If people don't respond yes, I know you're not watching. So I'm just going to wait a few more seconds. Right. I mean, Zaref, you've got even an issue not to be here, but you're here, but yet some other people aren't. That's disgusting in a way, right? The likes of Mirella, I mean, we're going to have some serious words with these people. So, okay, cool. Cool. Right, first one here. So what is this guy? 1 plus tan y is quite y. Yeah? dy. And this one's quite, I mean, I'm going to leave it as it is because it's still the same. We can integrate both of those quite easily. Now, you might say, what the hell? How do I integrate cot y? And I smile at you and I say formula booklet, right? So don't stress about, imagine if you want me to, again, it's another way. If you want me to demonstrate, I'm more than happy to demonstrate it. But it is in the formula booklet. And part of doing well in exams is knowing what you're given and what you need to memorize as opposed to what you actually can get away with not knowing. The integral of cot y is ln sine y. And you can literally, again, pull it straight out of the formula booklet, dy. And this guy here is another example of this thing, which is the integral of f dashed of x over f of x equals ln f of x. And you've seen that happen a few times. I'll just again put it so you can see that. The modular sign there plus c. Because if you differentiate x squared, you get 2x, which is almost what that is. Yeah? So you can write straight away that this integrates to a half ln 1 plus x squared plus c. Now, again, I need a yes or no on this. do you understand that if you integrate this, you get that and y? Okay? Don't worry about the plus c. The plus c is a bit funny. We'll talk about plus c in a minute. But do you understand y from here to there? Again, I need a yes or no answer. And if the answer is no, tell me what bit. Do you need me to explain it or what? Do you need me to demonstrate it? It's just literally this thing again. Okay, good. Well done, Reba. No. Okay, cool. Happy to do that. I'm going to do that. I'm going to have to rub this stuff out anyways. Can I ask you just to copy down what you've got up to here? I want to demonstrate for Farhan why that's true, because it won't take long. Why a half exactly? That's what I wanted to know if people wanted to know that or not. Good. Thank you for asking that, Kai-san. So I'm going to give you, take a minute, copy it out. All right. Remember, even if you don't manage to copy it out in a minute, it's like this is example 25, so don't stress. It's there for you, but I want you to copy out so you don't have to keep flipping back and forth. At 1 minute from now, I'm going to prove to Farhan and Kai-san why that's a half. And then I'm going to finish this question. All right. Then I'm going to do example 26. Then I'm going to shut up and go away. All right. To the relief of many, I'm sure. But you do need at least a couple of examples on this one. I'm not going to leave you halfway on these. So you've got about another 30 seconds to copy this out. And if you don't manage to copy out in time, just remember, obviously the video's here, you can use that anytime, but it's also example 25 in the textbook. So that hopefully won't be too stressful of a thing for you. That you can just, you can just hopefully look it up. Boom. What are these people? Okay. So if you haven't copied that, don't stress it. Just as I said, it's an example 20. It's example 25 and 323. The question was asked: how do I know that the integral of what was it? X over what was again? It was x over 1 plus x squared. And I could just look at that and go, well, that's just ln, a half ln 1 plus x squared. All right. Most people got why it was this, but the half was the issue. So the rule is this, right? If this differentiates to that, then you can just write it. The integral of that will just be ln of that. Denominator plus c. Yeah, forget the half of it. Yeah? So where the hell did the half come from? The half came from the fact that this doesn't quite work here. If you differentiate x squared, you get 2x, not 1x, right? So you need this to be 2x, but it isn't. So you put a half on the front to get rid of the 2. The half times 2 makes 1, right? And that's why the final answer is a half ln x, ln 1 plus x squared, sorry, plus c. And that's why that's the case. Now you might say, well, does the c need to be a half as well? No, don't stress about that. It's a constant. It's undefined. It's a number that might or might not exist. Halving a number that might or might not exist just give you another constant. All right? Okay, let's finish this. So I hope that made sense. I'm fine if it didn't, pop up in the chat box. If Kai said if it doesn't make sense to you why it's a half still, just remember if you differentiate this, you should get that. And if you don't, you need to fix it so you do. So differential of x squared is 2x. So I'll make it 2x, then put a half there to cancel out the fact that, it's not really 2, is it? Okay, so where were we in the question? So we were here. I want to be able to see the screen. So it goes ln sine y. That would be a moment. Ln sine y equals a half. What was that horrible thing? Was it 1 plus x squared? Brilliant. Well done, guys. Plus c. I'm glad you understand that now. Okay, sorry. My apologies. Obviously, there's an ln in there. So it's a half ln 1 plus x squared plus c. Okay. What do I do with all of that? I mean, it's all about laws of logs now, right? What can I say about this quite nicely? I can say that let's call C ln k, and that's what they do in the example. That's why the only reason I picked k. C is some number, so it's ln of some other number. Yeah. So for example, if you had ln of e, that would be 1. Yeah. We're just calling it that. We'll give it a name. So ln sine y, annoying, equals a half ln 1 plus x squared plus ln k. Now, if you did not understand that line, say so now, okay? All I've said is that constant is some number. If it's some number, it must be ln of some other number. Don't know what it is, but it's ln of some other number, all right? I'm going to make one change to the way, and this is me being very, very precious about stuff. It's not, I'm really being super picky about something for the next line. I'll explain when we get there, all right? But up to now, hopefully that makes sense. So if C is a number, it must be ln of some other number. Yeah? Okay. Laws of log say this then. So ln sine y equals k over 2 ln 1 plus x squared. That's just laws of logs. Just laws of logs. Just laws of logs, nothing else there. My apologies, k, sorry. My mistake, I'm being silly there. Because laws of logs say it wouldn't be a multiplier on the outside, it'd be on the inside. My mistake. So half ln k 1 plus x squared. My apologies. That's just me being stupid. Right, that looks right now. That all equals fine. Now, the half is a bit of an issue. And I mean, this is where I'm going to start being a bit awkward about things. Okay, it's a bit weird the way I'm going to do this. Because really and truly, the mathematician in me doesn't like that. Because that's a half and that isn't. So what I'm going to say is, let's just get rid of the half, all right? And go, okay, let's just treat that as, because that's a constant, let's put the half there instead and just deal with it that way. Yeah? And then go a half. And I mean, this is so petty, but you just want it to work out the way it does in the book as well. And the book is a bit awkward about stuff as well. But yeah, I'm going to go with that. That way we've got rid of the constant and the half's out of the way. I'm just looking at it, just thinking, well, that half doesn't look right. Then you can square root both sides. Yeah? Square root both sides. And you get, well, don't square both sides, just square root that. You get sine y, ln sine y equals ln. And then that's literally just going to be the square root of k plus 1 plus, so k times, 1 plus x squared. And then you can literally just go sine y equals root k1 plus x squared. Again, that's probably the nicest way you're going to get it, and it concurs with what they got there. And that's the way around it. Now, this is the time to ask questions. Why is k within the modulus sign? Because of laws of logs. Because of laws of logs. Especially the way I've done it now. Because, like, sorry, I'm going to fix the camera. That's not fixing the camera. That's the opposite of fixing the camera. You didn't get the second line from here to there. Okay, it's pure kind of, basically it's me playing fast and loose with the idea of a constant. If there is a constant c, which is a number, then that constant must equal ln of some other number, right? Or more specifically, a half of ln of some other number. Yeah? That's all it is. It's just me saying, I'm going to change the idea of the number C, the constant C, which I don't know what it is, but it's some number. And instead of calling it C, I'm going to call it half ln k, because if there exists a number C that's real and, you know, within the bounds and all that, then it can be written as a half ln k. Obviously, C is negative, you kind of stuff, but, you know, go with it on this. So we're just going to call C half ln k. And why is that? Because then we can turn it all into one big smoosh. We can put them in, instead of dealing with like a 3-parter, you've now got a 2-parter, an ln sine y. And you can see it simplifies and solves so much more nicely. So that's the reason why I'm going to replace C with half ln k. The mathematical justification is that if there exists a positive number C, there must exist a positive number half ln k that equals C. All right? Why do I choose to do that? Because it turns this into this, into this, into that, which is a lot simpler than that. Yeah? That's the logic. That's what you're chasing through. All right, so it looks like Kelvin showing up. Can you make sure you've sent me pictures of all your work, Kelvin? That would be super, super helpful. Okay, so I hope that's now making some level of sense. What I'm going to do is I'm going to leave that up for a couple of minutes so people have got time to complain. All right? In about 2 minutes, I'm going to go through example 26. I'm going to, for the rest of this lesson, I'm going to ask you to do the exercise. So if you understand all of this already, you might want to go straight to, I don't recommend it. I recommend you stay with me, actually. But if you really feel super confident, you are like literally the Superman of mathematics, go straight to 11J. I recommend hanging around for a bit. I recommend waiting, especially because like 26 looks like it's an absolute monster. And I'm going to hang around. I'm not going to rub this out until another minute and a bit. Yes, go on, you know. Let's see what your summarization would sound like. I'll wait on that. No, I wouldn't summarize it quite like that. I would say C, well, as long as C is positive, yeah? The only reason I put a half on it is just to make my life easy. Do you know what I mean? Because there was a half there, right? I mean, you don't have, the thing is, like, don't try and learn it as a memorized, this is what I must do under every circumstance. Just go, you're like a kind of like a mechanic. You try, you know, you deal with every situation as it is, you know what I mean? So right now, that was the thing to do. The thing I want you to kind of move away from is just going, I want to memorize a rule for every situation, because you'll end up with a head full of rules and you'll forget a few, right? The only reason I stuck a half on it was to make my life easy. If you look at the textbook, it gives you 3 different ways of getting to the same place, all right? So like, do you know what I mean? So the reason why I put a half in there was because it makes my sums work nicely, yeah? How would you know? You practice. And I mean, this is why I'm hanging around with you, to do another example so you see that, right? I know it sounds incredibly frustrating as a student to hear from a teacher, you get good at this, it will happen. But the truth of the matter is, you will get good at this and it will happen as long as you work, yeah? So I get that that's frustrating for you now. It's like, where did he pull this off? How is he doing this? But I promise you, once you practice it, you'll look back at it now, there's no problem. I get why this is true, yeah? The mathematical thinking behind this is going, I've got a half there, that's a bloody nuisance, if you really want to know, you know, right? How can I make, if I have that as lnk, and that's a half, I'm going to have to do some kind of maths to fix that. So why don't I get rid of one of my problems straight away by making it a half there? So that's my thinking anyways. But as I said to you, don't stress about that. Don't panic about that. You just think for yourself, okay, look, I'm here. What's going to make my life easy? Is it going to be easy if it's just lnk? Is it going to be, because I can make it whatever one I like. I can make it 1 over 37 million lnk if I want to. It's a constant. We don't know what it is. We can do what we want, right? Okay, don't worry about it. All I'm going to say to you is, I want you to develop the thinking skill of it. Just like, okay, I'm here. There's a half there. It's going to be super handy if that's a half. That's what I'd rather you understand, rather than, okay, I'm going to memorize an essay. Do you know what I mean? Don't be a flowchart. Do you know what I mean? If this, then that. All right? Be like, oh, boom, that's a half. Well, okay. what's going to be helpful here, because sometimes you'll end up with just too many flowcharts in your head. Right, I think that's long enough on this. I'm going to rub this out. I'm going to take you through 26, which is an absolute lengthy one. So can you have a look at 26 while I'm doing this? Because it'll make your life so much easier if you've got, like, if you can flip between the two. So example 26, let me tell you where it is. So example 26 can be found at the bottom of page 323. Okay? And we're going to go through that one together. And it says dy dx equals 3 minus 3, y minus 2, 2x plus 1, x plus 2. All right? Now, what I want you to do before we go any further is do the thing that you should be able to get, at least get 1 or 2 marks on any exam on, and that is separate the variables. All right, so I want you to separate the variables for me. Separate the variables for me. And you're going to come across one of the problems that most people have, especially starting out with differential equations. And we'll talk about it when you get to it. All right, so can I ask you for me, just for now, just for the minute. Oops, let's try and get this the right way. So we're looking at example 26, page 323. Can you separate the variables out for this guy? All right. And I'm going to hang around for a minute. You seem to have lost a few people again. So all you need to be doing in the next minute, minute and a half is splitting the variables. You don't need to show it to me. I mean, that seems reasonable. Remember, you can also check this as well because it's all in the textbook. And I'll come to one of the things that people often have a problem with. And I'll talk you through that in just a moment. First of all, yeah, do you know what, Iman? Great minds think alike. Because when I taught this last year, you did exactly what I did. And I want to convince you why that's, again, it's another one of those things where, what was the quote that you didn't like me saying? How to make my life easy, all right? So I want to show you how to make your life easy on this too, all right? And I fully understand why you did what you did there, because I did it too, all right? But I'm going to give everyone else a minute just to catch up with that. Then we'll talk about how we can make our lives easier on this. So you guys have got about another 1 minute, 16 seconds, all right? You should try and split it up. Check it against the answer in the textbook, the first couple of lines. Then I'm going to talk to you about why the textbook's right, why you're probably not wrong. You're probably not wrong. I'd be surprised if you got it wrong. But why you can do things to make your life easier. It wasn't a mistake here, man. I mean, I'm going to be absolutely clear with you. It wasn't a mistake. 10 more seconds. So people are starting to drop off. So can we just do another quick register on this? As I said, you need to be on all the time. Apart from Zarif, I know Zarif, if you're watching, I know what your situation is. So make sure you put your name. So Mohammed, so Kaisan and Iman, I know you're on. So other 2 people, just make sure 3 people now spot. It's amazing how, as I say that, people start popping back up. Right, okay, cool. So the way the textbook's done it is this. So yeah, keep popping your your things in your chat box. So I'm looking at the whole thing to see if anyone's being lazy or whatever. So this is 1y minus 2 dy equals minus 3 x 2x plus 1 x plus 2. And then you might say to yourself, VJ, well, what's the difference? The answer is nothing really, except it's the thing that really annoyed, and I understand you, man. I fully get why what I said before annoyed you. Making your life easy, yeah? because that goes straight to ln y minus 2. And if you put a 3 there, you've got to fiddle around with it. All right. And that's the only reason why it's a 1 there rather than a -3 or whatever it is. Yeah. Here, you're going to have to do algebraic partial fractions anyways. And that's the next thing we're going to do. Okay. So you may as well just lump the -3 here. If you put it there, a -3 just makes this one that little bit more complicated. Integrating this is incredibly easy now. You've got ln y minus 2. Now, the next thing I want you to do is integrate this guy. Okay, and to integrate this guy, you're going to have to split it up into 2 fractions, a to x plus 1 and b x plus 2. Can I ask you to do that? And come back with me with what those fractions are. I'm just going to pop a bit there. So again, it's the reason why I've chosen to put the 1 on the left-hand side and put a 3 on the right-hand side is quality of life. It makes my life so much easier if when I have a 1 over y minus 2, that just becomes ln y minus 2 when I integrate it. Now for you, for the second part, this guy here, you're going to have to break it down into partial fractions. Can you pop in a chat box if you don't know how to do that? You should do that. If you don't, you don't. If you can do that, can you do that for me? All right? Split this into partial fractions and then integrate. Yeah? So that's what I'm asking you to do. It should take you about 5 minutes, I think. All right? So for this one, you should be trying to work out what this is as partial fractions. Once you've got them as partial fractions, integrate them. All right? Integrate them for me. How many marks? Exactly. Iman, now you understand. Do you understand why this was taught the way it was now? You need all the bits and pieces for this. All of them. Yeah? For differentiation, differential equations. And it's like, this is why I'm not kind of overly stressed that your integration isn't as good as I'd hoped it would be. Because you're going to end up practicing it this way anyways. All right? How many marks is the question? Let's have a quick look. I would, well, I don't know if there's numbers on it. But you will have, like, when we do exercises, let's have a look at some of the standard exercises. I'll be able to give you an idea on that. I mean, there are questions that are like 13 marks long, and this could be one of them. Okay, so 12ABC, which is a very, very similar question, but easier. And remember, this is easier, was 12 marks. So, you know what? That could have, the one we're doing could easily be a 13 plus. There's no reason why it couldn't be. So what I'm looking for now is A and B. And if you are a strong candidate, if you know what the hell you're doing, you can integrate ahead. If not, I will give you A and B in about 2 minutes. So A is minus 2, B is 1. Remember, you can check this in the textbook as well, but I want you to do it. There's no point in you just going, oh, I understand. Or look at the textbook, oh, yeah, I understand. It's great. Okay. It's really, really easy if you're just reading from the textbook. I get that, but it's about another minute or so, then we'll carry on. If anyone absolutely cannot find A and B, can you pop it in the chat box in about the next minute or so I know that I need to teach it again? Quickly run through it. Yeah, of course I can. don't worry, remember all this stuff is available in the textbook. So the question was asked, can I do this for people? That's by all means. That's what I want you to do, ask questions. So we've got 2x plus 1, x plus 2, and that's going to be a over 2x plus 1, and then you've got b over x plus 2. So this is what we're going for, all right? So minus 2. Good. Right, let's just see, you can see all that. So that's what you've got. That's what we're going to do. You cross multiply, and you get ax plus 2 plus b times 2x plus 1. Yeah, I agree with that. That's 2 minus 1, isn't it? And what I'm going to do here is I'm going to use the expand and turn into an equation method because I can't bother with substitution because I'm lazy. So you're going to get ax plus 2a, that's just the expansion of that, plus 2bx plus b, that's just the expansion of that, equals minus 3. Okay? Because this is meant to equal that. And if you cross multiply that, you get this over that. And you notice that the denominator is the same, so the numerators must be the same as well. All right? Because they're meant to equal each other. So the equations you get, sorry, you can't see that level, so I'll pop it over here so you can, are that a plus 2b equals 0. So that's one equation. And then the second equation is 2a plus b equals minus 3. And it's just simultaneous equations at that point. I'd probably double this one, go 2a plus 2b equals 0. And then you've got subtraction on that. And here, 2a plus 4b, my apologies. So you end up going 2a plus 4b equals 0, 2a plus b equals minus 3. So you get 3b equals minus 3, b equals minus 1. So it follows logically that a would be, no, sorry, 3b would minus 3, yeah, that's fine. What would you get for a? Is that quite right? Let me just check that one. So yeah, you got b's minus 1, got that right. Put minus 1 into there. You get minus 1 equals minus 3. So 2a, you'd be going what? You saying a is 2. A is minus 2. Okay. Well, yeah, I see that. Yeah, I see that. That's fine. Yeah. Just checking on that last one. Have I screwed it up somewhere? That's 2a plus b. No, it's 2a plus b equals minus 3. I've got b equals minus 1, which is right. So you get a minus 2 equals 0, so a must be 2. Then you got 4 minus 1. Is that 2a? Have I copied it out right? I'm just seeing where the error is. Let me just check what the actual answers are. I'm being more stupid than normal. A plus x plus 2, yeah, that's a plus 2. So you get ax plus 2a, yep. 2a plus b, yep. A plus 2b. I agree with that too. So minus 3, b is. They've gone with. What have they gone with? Where have I made a mistake here? 2a plus 2b equals 0. That's true. So anyone spot the mistake? Because it's almost right. There's an error there. I can't just see it though. The top equation, would it also equal to minus 3? No, it wouldn't. Because these are multipliers of x and there isn't one. So a plus 2b equals 0 might. Now I hear what you're saying on that, but that's not the problem. There is a problem in there, clearly. Maybe I miscopied it or something. Entirely possible. Let's check. Knowing me is entirely possible. A plus, okay, so ax plus 2, b 2x plus 1. Yeah, that's all over that. So that all equals minus 3. So we can go a times x is ax, a times 2 is 2a, b times 2x is 2bx, and 1 times b is b. Fine. That all equals to minus 3. So 2a plus b equals minus 3. Fine. If you multiply that through, you get 2a plus 4b equals 0. Because you're subtracting. Because you're subtracting, aren't you? So obviously that's positive 3. My mistake. It's literally, I knew it'd be something dumb like that. So you've got 2a plus b equals minus 3. If you subtract them, you get 3b equals positive 3. So b equals 1. And if b equals 1, then a equals 2. quite right? Is that minus 2? Minus 2, yeah. A equals minus 2. There we go. So A equals minus 2 and B equals 1. Beautiful. Anyone confused by that, other than the fact I can't do sums? But that's no surprise, is it? You've been here long enough to know that. Yeah, so we've got B equals 1 and A equals 2. Yeah? Minus 2. So B equals 1 and A equals minus 2. If anyone's confused with that, just follow through the working out on the thing. They're annoying, these questions, aren't they? Not difficult, but they're annoying. Right, cool. Let's finish off the integration now. Get it over and done with. Because we now know, we worked out a long time ago that the right-hand side was going to be ln y minus 2. We did that like 10 minutes ago. It feels like it. Now we're integrating 1 over x plus 2, and then you've got minus 2 to x plus 1, which works out beautifully because that will literally just go ln y minus 2 ln x plus 2. This is just, again, law, you know, the integration where if you differentiate the tops, that will be a minus sign, sorry. ln 2x plus 1. And I'm just going to go straight to ln k at this point because we know it's a constant and all the arguments about constants are still true. All right? Again, any particular issues with that, drop me a comment. Because all we're doing, so you can see the bloody thing, that would be a good comment to start with, wouldn't it? I can't see the bloody question you're doing. Bear with. I don't know why it's being annoying. There's something wrong with the camera, I think. Okay, cool. That's about. Sorry, that's really dismal. Just let me fiddle with the camera for a bit. I like in my house. Oh, it's because this is. I was wondering. Right, cool. That makes so much more sense now. Sorry, I do apologize. Right, have a look at that. So the left-hand side is what it is, all right? Because we knew it was 1 over y minus 2, so that'll be ln, right? Integral of this, that integrates to that integrates to that. Why is there an ln k? Because there's a c, yeah? And if there exists a c, there must be an ln k, right? We can obviously now put that all together into one big thing by saying ln y minus 2 is just going to be a bunch of k ln. Let me just see this. I might have to move the camera again. Kx plus 2 over 2x plus 1. Close mod. I think that makes it a bit more clearer. Right. Okay. And now, again, you need to tell me if you understand that or not. So what I did was I integrated this side already. I integrated that side. I put all the logs together. Can cancel the lns as well after that. And then the question is different because it actually asks you to find k. So I'm going to take a minute. I'm going to take a little breather. Like, if anyone needs to say something in the comments. All right? Is it frozen? No, I'm just waiting in case anyone's got any problems. I guess by that comment people don't, which is great. So let's just finish this. What the hell is that? Okay, cool. Anyways, let's just finish it from here. So you've got to this point. Hopefully you've copied it out by now. So you can go to this point, which is y minus 2. I forgot what it was. I'll write it out. Equals k lots of x plus 2 and 2x plus 1. And if you happen to have a coordinate, and in this example you do, Let me just go back and remind myself what the actual coordinate was. The coordinate is 1, 4. You could literally just substitute those values into there. So go, I don't know, y minus 4 equals k. 1 plus 2 is 3. 2x plus 1 would go 3 again. It would just be k. So k equals y minus 4. Also, why would I put y minus 4? I'm being stupid. It's 4 minus 2, which is 2, wouldn't it? So yeah, just substitute coordinates into that. And then you get a value for k, which I think would be, let me just check it. Well, I'm not checking the sum or anything else. It's, yeah, so k is just going to be 2 at that point. And you've got the whole equation, and you know what the constant is too. All right? That's it for me, because that's been how long? 55 minutes. So here's how this is going to work, right? I want you to do as much of, and I mean a decent effort this time, 11J as you can in, say, the next half an hour. We'll pick it up again on Thursday, and we'll also do some mechanics on Thursday, all right? I need to see an improvement for some of you guys in the work. Some of you guys, I would say right now, I'm happy with Eman, and I'm happy with Reba, I'm happy with Kai-san, and I'm happy that Shiying, you're trying at least. I mean, not some of the homework on Dr. Frost isn't perfect, but it's there. All right? But anyone else, Thursday is when the hammer's going to fall, all right? 11J, page 324. Send me pictures on Thursday, not now, all right? Because I want you to do a few of these, okay? And that's me done for today. Take care, look after yourselves. You finished your work on Dr. Frost? Excellent, brilliant. One less thing to worry about. Definitely put in work, yeah, fair shout, yeah? If you change how you are, and you change it for the better, it's a blessing, all right? Look after yourselves, look after your families, take care, and I'll see you all on Thursday. Any issues or problems, drop me an email or on Microsoft Teams anytime, all right? Look after yourselves, my dudes. 3 more weeks, hopefully 4 more weeks. I don't reckon we'll be in college before June, though. We might be allowed to go out on the street a bit more, but, you know, I say look for June. Okay? Same for you, man. You and your family, hopefully, stay safe as well. All right? Take care.